Hello everyone, my name is Keheliya Gallaba. I'm a software engineering researcher at the Huawei Center for Software Excellence in Kingston, Canada. Today I'm going to talk about lessons from 8 years of operational data from a continuous integration service. In this work, we conducted an exploratory case study of CircleCI as part of my PhD. In today's software teams, continuous integration is ubiquitous. Developers push their changes into version control systems frequently, triggering the CI process. This builds the changes, tests them, and report the results back to the developers. Continuously doing this process is called continuous integration. Some organizations go a step further to do the deployment into production also continuously. We call it continuous deployment. And some even go further to collect telemetry data continuously from production data to do continuous experimentation. CI builds can be triggered in different stages of the software development process. For example, during the development time, developers can initiate CI builds to try out their changes, or during the code review time to verify the changes, or just before they are being integrated into the version control system, CI builds can be triggered. All these CI build requests go through a build job creation service in the CI system. Depending on certain conditions, build jobs are created and put into a build queue. Then a build job processing service picks up these jobs and executes the build. Results of these builds are put into a result queue. Based on how the notifications are configured, build job reporting services will pick up these results and notify different channels via email, Slack, and web dashboard. However, maintaining these infrastructure in-house is challenging. Therefore, more and more organizations are moving to cloud CI services such as CircleCI, Travis CI, CodeShip, and GitHub Actions. Previous research have looked into many aspects of continuous integration. For example, El Sahari, Pinto, and their teams have looked into benefits and challenges of CI adoption. Also, Hilton and their team has looked into these benefits and challenges as trade-off. Some have looked into the outcomes of CI and their duration. For example, Carmine and his team looked into build failure specifically. We have looked into the noise in build outcome data. Gallaba and all looked into the long duration of CI build. Then there are CI patterns and anti-patterns. We looked into the use and misuse of CI features. Then Zamperi looked into the empirical characterization of bad practices. Then again, Vassallo looked into the automated reporting of anti-pattern. However, the CI service provider's perspective is largely unexplored. By looking into the CI provider's perspective, we could uncover opportunities to improve the CI services. For example, operational cost to maintain the server infrastructure can be reduced by the CI service provider if we look into how the builds are being executed globally. Then, instead of optimizing for individual users, we can look for opportunities to globally optimize performance of the service. Also, if there are certain aspects affecting the user experience, we can look into them as well and improve the user experience. So we focus on 3 dimensions in our study. First, usage of CI service over time. The signal generating builds, where a signal is provided to the user based on the outcome of the build, such as the tests passed or failed. Or non-signal generating builds, where the builds were terminated abruptly and therefore unable to provide a signal to the user. To do this study, we focus on the popular CircleCI service. It's been reported, been used by 1 million developers, therefore the impact is huge on the software development community. Then there are over 748,000 installs as reported on the GitHub Marketplace, showing that it's been used by many software teams. Also, it provided a robust API for us to access historical data for over 8 years. In our exploratory case study, we started with the Google BigQuery dataset, where the GitHub project data is hosted. We selected projects that use the CircleCI service and retrieved their build information using the CircleCI API and cleaned them up. This gave us 22.2 million CI builds over 7,795 projects. We used this build data to answer our first research question. Next, we divided them by signal generation status to answer our research question 2 and 3. First, let's look at the first dimension, usage of CI service over time. Here, we study growth of CI usage for the 8 years from 2012 to 2020. We look at 4 indicators. First is build duration. Build duration is the time taken to execute the build. Then there is throughput, which is the number of builds completed in a fixed amount of time. Then there's mean time to recovery, which is the time taken for the development team to go from a build failure to a passing build again. Next, there's the success rate. Success rate is defined as the amount of passing builds as a percentage of total builds in a given period. In the interest of time, we focus on 2 indicators, build duration and throughput. Here you can see the median indicator values for build duration and monthly throughput in this plot here. They have remained stable over time, showing that CI service was able to provide a consistent service for their customer base. However, if we plot the 95th percentile on top of this graph, we can see the throughput and build duration have been increasing among the heaviest consumers over time. This means we need to provide some extra attention to these heavy consumers. Based on these results, we decided to look into the resource consumption among the consumers. For that, we look at resource consumption indicators, total build time and throughput. We compute these 2 indicators for all projects across all the months in the studied time period. Then we use the Gini coefficient to quantify the inequality of resource usage. Then we plot the result. We found out for throughput, the Gini coefficient was increasing over time, showing that the heavy users are taking up more and more resources over time. Then we look at the total build time indicator, and it also confirmed that the inequality is rising. The active users are taking up more and more resources over time. This means more steps needs to be taken to tackle the resource consumption by the heavy users. To summarize, consistent service for the regular consumers is provided by the service. However, resource consumption by the heavy users is growing further. Based on these results, we decided to look into signal generating builds and how these different groups of users are spending time in their builds, in the signal generating build. We study how time is spent in builds of heavy consumers versus typical consumers. For that, we computed runtime percentage of each action type in the builds for heavy consumers and typical consumers. Then we applied statistical tests, man-Whitney test and Cliff's delta, and obtained the results. Here we can see the plot of runtime percentage for one action type, which is tests. And we have two plots for heavy users and regular users. We repeated this for all the action types. Here you can see there are statistically significant differences between heavy users and other builds. But since we need to pay more attention to heavy users, one result pops out. Here we can see heavy user builds are taking more time downloading dependencies. This means dependency installation optimization will benefit the heavy users and therefore will affect the global resource consumption as well. To summarize, for the general population, compiling and tests take up most of the build runtime. However, for heavy user builds, they are spending more time downloading dependencies. Now we move on to the third research question, non-signal generating builds, where builds are abruptly terminated without providing a signal for the user. We use open coding to study the reasons why builds fail to generate a signal. We start by selecting a random sample of non-signal generating builds. Then we use API responses, build logs, and Git commits to identify the circumstances that led to these builds being abruptly terminated. To validate these codes, we measure the agreement between automatic and manual labels. Finally, we use open card sorting to construct a taxonomy of codes. Based on this, we found out 4 general themes about non-signal generating bills. First one is user cancellation, bills abruptly terminated by the user. We found out over 786,000 bills that were abruptly cancelled by the user. Then there were availability issues. For example, bills were terminated because the CI service or the supporting services were unavailable. We found out 372,000 such bills. And then there were configuration errors, bills that were terminated because missing or outdated CI configuration files. There were 31,000 such bills. Finally, there are bills that were exceeding time limits. For example, if no output was provided from any of the commands during the builds, CircleCI was terminating such builds if they were running for longer than 10 minutes. We found out 18,000 such builds. This shows that if the CI services want to reduce the non-signal generating builds, they can start by looking at these 4 reasons. For example, starting with the user cancellation. To summarize, we found out 4 themes for non-signal generating builds: user cancellation, availability issues, configuration errors, and exceeding time limits. Next, we provide recommendations to address current limitations in CI services. To reduce the load on the CI service, tools and techniques for build acceleration can be used. For example, Abdul Karim et al. Has provided a machine learning approach to skip certain CI builds. Similar work has been done by Jean and Savant as well. These approaches can be used by the CI service provider to reduce the build load on the server. Then, if the CI service wants to impact a large number of consumers, they can optimize the compilation and testing stages. For that, they can use techniques such as test selection. Here you can see recent research done by She and the team in terms of regression test selection. Then there are other approach for test selection, such as this predictive test selection used at Facebook. CI service providers can look into adopting these techniques in the CI service itself to benefit a large number of consumers. Next, due to the high number of user cancelled builds, CI service can look into user research to identify reasons behind this to reduce the amount of non-signal generating builds. To conclude, cloud CI services are becoming very popular. We focus on 3 dimensions in our study: usage of CI service over time, signal generating builds, and non-signal generating builds. We have many observations along these dimensions. Also, we provide recommendations based on these observations to improve the CI services. Here you can find my contact details. If you have questions, please feel free to contact me. Thank you very much.